Okay, so let's be honest here. We've all seen how powerful AI applications are getting, right? But
Yeah,
getting them to actually talk to each other, to share data tools easily.
yeah. It's often a real headache.
It feels like you're constantly trying to, fit a square peg in a round hole.
Lots of custom integration, one piece at a time.
Exactly. Well, today we're going to dive into something that maybe promises to change that quite a bit. We're talking about a concept called MCP. And just to give you the main idea up front, think of MCP like a USB-C port, but for your AI apps.
Okay, I like that analogy.
Yeah, just like USB-C gives you that standard way to connect, all sorts of devices and accessories. MCP wants to do the same thing for how AI apps connect to data, tools, maybe even other AI models.
That's a really helpful way to picture it. And yeah, our mission for this deep dive is basically to unpack what MCP actually is, how it works under the hood, and maybe most importantly, why this kind of standardization really matters for where AI is going. And we're drawing heavily on the work of Dr. Anthony Onoja from the University of Surrey in the UK. He's laid this out very clearly.
Okay, great. So we have that USB-C analogy. Let's unpack this then. You mentioned how it works. At its core, I understand it's a client-server thing.
That's right, a classic client-server architecture.
So you've got a host application connecting to multiple servers. Could you break down those key parts, like host, client, server?
Sure. So the host is basically your main AI application. Think of something like maybe the Claude desktop app or Cursor, that kind of thing. It's the environment where the AI interaction happens, where you access tools and data. And crucially, it's where the MCP client runs.
Okay, so the host runs the client, and the client, that's the piece talking to the outside world.
Exactly. The MCP client operates inside that host, and its job is to handle the communication with the MCP servers.
Got it. And the server, what's its role in this picture? Is it just holding data?
That's where it gets interesting. The server is much more active than just a data store. What's fascinating here is how the server acts as this dynamic gateway. It actively exposes capabilities that make the whole system really powerful. It's not just passively waiting for a request.
Okay, exposing capabilities. That sounds key. What kind of capabilities are we actually talking about here?
Yeah, there are three main types, three essential categories that a server makes available. First, you've got tools. These are what let the large language models, the LLMs, actually do things through your server, like maybe call an external API, run some code, perform an action.
Okay, so the LLM can use server-provided tools. What else?
Second is resources. This is more about
Excellent.
exposing data or content from your servers directly to the LLMs. Think of it like providing specific information, documentation, context that the LLM might need.
Got it. Tools for actions, resources for information, and the third.
The third is prompts. This allows for creating reusable prompt templates or even structured workflows. It helps make interactions more consistent, more efficient,
Right, so you're not reinventing the wheel every time you ask for something similar.
precisely.
Okay, tools, resources, prompts. That structure makes sense. But maybe a concrete example would help lock it in. The source mentioned a weather API server. How would that work? What would it actually expose?
Yeah, that's a perfect example. So imagine a weather API server built using MCP. It would offer tools, right? These would be the functions to call specific API endpoints, get current weather, get the forecast, that sort of thing.
Okay, so tools to fetch the data.
Then it might offer predefined prompts, like templates for common questions. What's the temperature in city tomorrow? That helps the AI client ask the question in just the right way the server expects.
I see. Makes the request cleaner.
Exactly. And finally, it could provide the API's own documentation as a resource. So the LLM could actually look at the documentation if it needs more detail on how the API works or what data it provides.
That's actually really clever. So the LLM could almost read the manual itself if needed.
And kind of, yeah. It shows how those three things, tools, prompts, resources, work together to expose the whole functionality.
That is incredibly practical. Okay, so we know what the server exposes, but the how is critical too, right? How did the client and server actually start talking and, keep that conversation going? Understanding that communication flow seems essential, especially if you're thinking about building something with MCP.
Absolutely. You're right. The handshake and the ongoing communication are vital. It starts off quite structured. First, there's what's called a capability exchange. The client basically asks the server, hey, what can you do?
Okay, so it requests the menu, basically.
Sort of, yeah.
Yeah.
The server then responds with all the details. Here are my tools, my resources, my prompts.
Right.
After the client gets that information, there's a quick notification step. The client just confirms, okay, got it, we're connected. And from that point on, the richer message exchange just carries on. And connecting this back to the bigger picture, that initial handshake is crucial. It makes sure both sides are on the same page about what's possible right from the start.
Gotcha. Avoids confusion down the line.
Mm-hmm.
So what does this all mean in practice? You mentioned the communication. Is there something fundamentally different here compared to, say, traditional APIs?
Yes, absolutely. And this is probably the biggest differentiator, the real game changer. Unlike most traditional APIs where the client just asks and the server responds, MCP communication is properly two-way.
Two-way? How so?
Well, it allows for something really interesting called sampling.
Sampling?
Yeah. This means the server can actually leverage the client's AI capabilities. The server can ask the client's LLM to perform a generation or a completion task using the client's model.
Whoa. Okay. So the server can ask the client's brain to think about something.
Exactly. Imagine the client has some special, maybe private, fine-tuned model, like for medical diagnosis or specific financial analysis. The server can tap into that expertise without needing the client's API keys, without even needing to know the details of the client's model.
Wow. Okay, that is different. So the server doesn't need credentials for the client's model.
Nope. And this is important, the client always stays in control. The client manages access, permissions, which models can be used for sampling. It's not a free-for-all.
Okay, that's crucial for security and privacy, I imagine.
Definitely. It enables this kind of secure, on-demand, collaborative AI intelligence without forcing anyone to share their proprietary models or data inappropriately.
That really does shift the dynamic, doesn't it? It's not just client asking server anymore, which brings up a really interesting question for you, the listener. How does this two-way street, this idea of sampling, really change how AI applications could potentially interact? How does it move us beyond just simple requests and responses towards, well, something more like shared intelligence?
It really does open up possibilities. I mean, this kind of standardization, this two-way flow, it could genuinely streamline AI development. Think about breaking down those data silos we talked about at the start.
Right, square peg problem.
Exactly. And it could enable much more flexible, much more powerful interactions between AI systems than we typically see today. It just allows for a more fluid exchange of both information and capabilities.
Which maybe helps us deal with that feeling of just being drowned in data.
Potentially, yeah, by providing clearer pathways for AI to connect and use information more effectively.
Okay, so let's try and wrap up the core idea here from our deep dive into MCP. What we've seen is it offers this standardized, yes, but also two-way communication protocol. It really acts like that universal port, that USB-C for AI applications we mentioned, letting them easily share not just tools and data resources, but even their own unique AI capabilities, their own intelligence.
And the why you should care part? Well, this standardization could really speed things up. Less time integrating, more time innovating. Breaking down barriers between systems, it could lead to AI interactions that are way more flexible and, frankly, more powerful than what we generally have now, avoiding some of that info overload by making connections clearer.
Right. Which leads to a final thought to leave you with. Imagine a future where, well, pretty much any AI application you use could be a super specialized research tool, could be your everyday writing assistant. Imagine it could just seamlessly tap into this huge ecosystem of data, tools, and processing power from other applications, where they can share and leverage each other's strengths without all that friction we currently face. What kind of possibilities does that truly open up for innovation? And maybe more personally, how might that change the way you interact with AI in your daily life?